Okay, in number 33, we have a function, and it's x divided by x plus 1. And we're supposed to plug in this value. If you remember, this is function notation. This f tells me to go use the function f of x over here. And the part on the inside is the x that I'm going to plug in. That's what the x and the f of x stands for. If there's a number in there, that means we go, and everywhere we see an x, we're going to plug in that 1 minus square root of 2. And it was x on top, and it was x plus 1 on the bottom. All right, so we plug it in, and now we just got to simplify. This is the same thing as evaluating a function. It's just plugging a number in. Our number just looks a little weird this time, and they're just giving you a little practice at what you would do if you had to do this. Well, on the top, we have 1 minus square root of 2, and on the bottom, we have 1 minus square root of 2 plus 1. Well, that's going to be 2 minus the square root of 2. All right, we look at that. It's plugged in, but we haven't written it in a nice, polite form, have we? So we want to get rid of the radical on the bottom, but it's in an expression. I'm going to group these together like this. And if you remember, if we have two terms of binomial and there has a radical in it, to get rid of the radical, what we have to do is we multiply by the conjugate, which means copy the same two numbers down, and instead of a minus, I'll put a plus. Whatever the sign is, you just switch it. And if you remember, that was to get a difference of two squares pattern. And if I do something to the bottom of the fraction, I'm going to have to do it to the top. That's a 2 underneath that top one also. I can't really fix it well with a stylus. All right, so and on the bottom, we have a difference of two squares pattern. This is a minus b, and this is a plus b, so it's equal to a squared minus b squared. Well, what's my a here? It's 2, so that's going to be 2 squared minus, and the b is square root of 2 squared. So that's 2 squared minus the square root of 2 squared is just 2, and 4 minus 2 is just 2. So on the bottom, I just have 2 now. That's the easy part. Now on the top, we're going to have to distribute. So I'll use some colors for that. We go back up to the step before. 1 times 2 is 2, and 1 times square root of 2 is square root of 2, and they're both positive, so that's going to be positive. All right, now negative square root of 2 times 2 is negative 2 square roots of 2. Draw that bracket on out there. And negative square root of 2 times a positive square root of 2 would be a negative, and the square root of 2 times square root of 2 is 2. Okay, now let's put all this together. On the top, I have 2, and then I have a minus 2, so those are going to cancel out. And then I have a 1 square root of 2 minus 2 square roots of 2. That would be a minus 1 square root of 2 over 2. And we would just write that as negative square root of 2 over 2. We would not put the 1 in. And that's their answer there on 33. On number 35, they want us to show that 3 plus square root of 5 and 3 minus square root of 5 are roots of x squared minus 6x plus 4. Well, how are we going to do that? If it's a root, a root means it's a solution. And what's a solution? A solution is something that if I plug it in to the equation, I get a true statement. In other words, when I would solve x squared minus 6x plus 4, if you remember what we would do, we would set it equal to 0. So if I plug either one of these numbers into that equation, I should get 0. Okay? So that's what we're going to have to do. So it's going to be 2 steps. We're going to have to do each one separately. So the equation is x squared minus 6x plus 4. And we're going to do the first one. We'll do this one first, and I'll plug it in. Everywhere I see an x, I'm just going to plug that in because it's supposed to work and be a solution. Let's see if it does equal to 0. I'll put a question mark. Does it equal 0? If it does, it's a solution. Okay, now you kind of might look at this and go, you may be already realizing it, but I've got 3 plus square root of 5 squared. That means there's 2 copies of it. Now you could look at this as a perfect square pattern, not a difference of 2 squares, but a perfect square pattern. Or you could FOIL it out or distribute it out. I'll go ahead and do that. 3 times 3 is 9. 3 times square root of 5 is 3 square root of 5. This square root of 5 times 3 is another 3 square root of 5. And square root of 5 times square root of 5 is 5. Okay, so now let me go ahead and simplify all that piece. 9 and 5 is 14. And I've got 3 square root of 5 plus 3 square root of 5. That would be 6 square root of 5. Okay? Now let me go work on the second part of that over here. I'll do it in green so that we can see This is a minus 6 times 3. That would be a minus 18. And a minus 6 times a square root of 5. That's hard to read, but that's the square root of 5 there. Would be minus 6 square roots of 5. So let me copy that down on these next two lines. Minus 18 minus 6 square root of 5. And then at the end I have this plus 4 that I just need to add on. And what we want to know, do these things, do they equal 0 when I simplify here? Let's see what it does equal. Well, I've got 14 minus 18, that's negative 4, plus 4 would be 0. So all that would end up canceling out because those things add up to 0. And then I've got 6 square root of 5 minus 6 square root of 5, and that is 0. So does it equal to 0? Yes. What we just showed by plugging it in and showing that that equation does equal to 0, when I plug that in, that shows that that is a solution. Now we have to do the same thing with the second one, 3 minus square root of 5. So it's x squared minus 6x plus 4 equals 0. We want to see if it works, and we're going to put a question mark over this. And now what we're plugging in is that second one, and I'll just do it in green. It was 3 minus the square root of 5. So if I want to show that it's a solution or a root, I'll show that when I plug it in, it equals 0. All right, now again, this is 3 minus square root of 5 times 3 minus square root of 5. If you need to, multiply it out with FOIL. I'm going to do it a faster way because we're trying to, improve our math skills here. This is a perfect square. You say 3 times 3 is 9. You do the first two things. You do the second two things. Square root of 5 times negative square root of 5 times a negative square root of 5 would be a positive 5. And then if you look, this right here would be minus 3 square root of 5. And this right here would be minus 3 square root of 5. So that would be minus 6 square root of 5. Okay. Now let's look at the second little piece here. Let's distribute this. Negative 6 times 3 is negative 18, and negative 6 times negative square root of 5 is a plus 6 square root of 5. So let me copy that down here. All right, and then I've got on the very end, we've got the plus 4. Does it equal to 0? Okay, now it's time to start putting stuff together. 9 plus 5 is 14. 14 minus 18 is negative 4, and negative 4 plus 4 is 0. Okay, let's look at the other part. Negative 6 square root of 5 plus 6 square root of 5, those add up to 0. And 0 plus 0 is equal to 0. Yes, we just showed that was a root as well. I'm just going to make some comments on 37. If you have 2 square root of 5 minus 3 square roots of 2, and they want to know the conjugate, all they're asking you to do is just write that same thing with the plus in the middle. That's the conjugate. For the B part, they want the reciprocal of the conjugate. So what you'd have to do is you'd have to say that's 1 over 2 square roots of 5 plus 3 square root of 2, because remember, this is its conjugate over here. Now you're going to have to simplify that, and that I'm going to leave for you to do because I've done some other examples, and you don't need to be able to just copy and everything. You need to be able to do this on your own. So remember, you'd have, if you're stuck and not sure what to do, you're going to have to multiply both of these by the conjugate of the bottom. To simplify this, you're going to have to say that's 2 square root of 5 minus 3 square root of 2, and 2 square root of 5 minus 3 square root of 2, and you just got to multiply that out and simplify it. Now the C part is asking you what's the conjugate of the reciprocal of 2 square root of 5 minus 3 square roots of 2. So the reciprocal of 2 square root of 5 minus 3 square roots of 2 would be 1 over 2 square root of 5 plus 3 square root of 2. And if you're going to find the conjugate of that, the conjugate of the reciprocal, that would be, this is the, okay, let's see. Let me do that again. Let me think. What's the conjugate of the reciprocal of 1 over 2 square root of 5 minus 3 square root of 2? So you'd have 1 over 2 square root of 5 minus 3 square root of 2. That's the reciprocal of that. And now you got to find the conjugate of it. So you're going to have to simplify this. And then after you simplify it, you'll take the conjugate of what you get. That's confusing. But you can work through it and do it. just one step at a time. I just wanted to give you these hints on how to start it. But I don't want to work it all the way out for you. Do you want to do 39? 39, you got the Pythagorean theorem. And you got x on this side. And you got 4 plus square root of 2. And you got 4 minus square root of 2. And they're wanting you basically to find x. Well, the Pythagorean theorem is that you take the two legs and you square them and add them, and that's equal to the hypotenuse squared. And my hypotenuse here is x. So I'm taking 4 plus square root of 2 and squaring it. And then I'm adding in 4 minus square root of 2, because that's the other leg, and squaring it. And that's going to be equal to x squared. Okay, now, in order to work this out, you're going to have to say there's 2 copies of 4 plus square root of 2. And there's 2 copies of 4 minus square root of 2. And then that's equal to x squared. Okay? So now we got to multiply it out. This is going to be 16. That would be 4 square roots of 2 plus another 4 square roots of 2 is 8 square root 2. And then square root of 2 plus square root of 2 is 2. Now if we come to the second set, I'll do it in blue just so you can see the difference. 4 plus 4 is 16. 4 times negative square root of 2 would be negative 4 square roots of 2, but then there's another negative 4 square roots of 2. So that's negative 8 square roots of 2. And then negative square root of 2 times negative square root of 2 is a positive 2. Okay? So let's see. We've got that plus 8 square root of 2 and the minus 8 square root of 2 are going to cancel out. I have 16 plus 16 is 32. And 32 plus 4 would give me 36. That's what x squared is equal to. So if I square root both sides, normally I would put a plus or minus, but because we're talking about a length here, we know we're not going to have a minus length. So we're just going to look at the positive square root of 36, and that is 6.